Hello friends, in this tutorial I'm going to explain the concept of the object registry, and you will understand that why this object registry is very important for OpenFOAM. So it is something like central registry, and which is going to register whatever the object or IOobject you are creating during the simulation, and that you can use later for your solver modification and the library modification or the boundary condition modification. So in next coming tutorial, I'm going to explain how to derive new boundary condition, and I'm going to create some basic boundary condition to some advanced boundary condition, and also we are going to do some solver modification. So before going to that aspect of the OpenFOAM, it is important to understand this concept. You cannot imagine a situations where you are not going to work with the fields or physical models or dictionary or the time. So this all things is going to required when you are going to do the simulation in the OpenFOAM. That is why this object registry concept is very important, because those fields, those times, and those registry you are going to use in if you are going to modify the field values. For example, if you are using the boundary condition, then you need to do call those fields or those time registry. So let me start with introducing the object registry. Okay, so what is the object registry? So object registry is a hierarchical database that OpenFOAM uses to organize its model related data. So what is the model here? Model is the solver you are using or the library you are using. Okay, so whatever the data you are using for your solver, or you can say for your boundary condition or libraries or utilities, the OpenFOAM organize the data related to those solver or those libraries or those utilities, and that data organization is in the form of the hierarchical. That is what called as the object registry. So for example, I can say that whatever the IO objects you create during compiling or running your solver, or whatever you may use, or the fields and dictionary, everything is registered in the class time name. Okay, so first it will create a class of the time, and whatever the data you are going to use, that is registered under those class in a hierarchical database that is called the object registry. Now next question is that why object registry is required. Okay, so you know that we generally use the finite value method in OpenFOAM. Finite area method is also possible. Finite difference method is also possible. So to use those methods or those techniques in OpenFOAM, it is generally easy to code those equations, long equation in the form of the snippets. Okay, so if you are writing those things in small codes, then it is easy if already one registry is available somewhere in OpenFOAM, so that any data you want to again use in those small codes, you can just call those data from that registry. So that is why object registry is very important. So if someone else wants to do some other modification in the solver, then he can easily call those data from the object registry, and he can do the modification whatever he wants. That is why OpenFOAM use the concept of the object registry. Now this is the hierarchical, this is the inheritance, or you can say that the class structure of the object registry. Okay, like but before that, let me go to the OpenFOAM documentation and let's understand that what is written there. So if I type here object registry, okay, so let me open the .h. So you can see that object registry is being derived from the three classes, that is the hash table, registered IOobject, and the word list .h. Okay, so here we should understand the this is the this is the derived from the hash table and the registered IOobject. So if I open the folder here, we can see here that this two class is being derived in the object registry, that is the registered IOobject and hash table. Okay, now you can also observe that this hash table is calling the pointer of the registered IO object. Okay, so this hash table is calling the pointer of the registered IO object. Now this is the very advanced concept. The multiple inheritance concept is being used here. So this is very advanced concept, but you should understand that what does it mean by here, that objecttree is a registered IO object. Okay, so it is being derived from the registered IO object. So you can say that object registry is a registered IO object. Also, it it gives the hash table of the registered IO object. So this is the two things you can say, that it is also a registered IO object, and it is also a hash table of a given registered IO object. Okay, so these are the some methods here. Okay, so we are going to do some codings where I will explain you about this registered IO object and the object registry. So let me open this thing also. Now you can see here that registered IO object is being derived from the IO object. There are other classes also. We are not going to discuss other things. We are just focusing on the three things. That is the IO object, object registry, and the registered IO object. So here you can see here the registered IO object is derived from the IO object. Okay. Now there are no anything related to our present topic that is being derived in the IO object. Okay, so there are other classes are there where which has been derived in the IO object that we are not going to discuss here. So here I can explain the this structure here. So you can see that IO object is not being derived from the any other classes, but IO object is being derived in the registered IO object. Okay. Now this registered IO object is being derived in the object registry. Okay. And there are other classes also like IO dictionary, IO field, and dimensioned field that is being derived into the that is being derived from the registered IO object. Okay. So what it is means that whenever you declare a IO dictionary or IO field or dimension field, this whenever you declare these things, it is going to be registered in IO object registry using the concept of the registered IO object. Okay. Now the most important object is that is time, that is also being derived from the object registry. Okay. Now you can observe that here is a one pure virtual function, that is the write data. So let me show you that. So it is the definition of the registered IO object. So let me open the definition here. So here you can see that this is the pure virtual function. Okay. So what is the concept of pure virtual function? So whenever you declare any virtual function in a class, then that class is called as the object class. Okay. So what does it mean? That you cannot directly create an independent object of that class, that abstract class. If you want to use that abstract class, then you have to declare those class into the some other class. Now when you are going to inherit that class into the another class, then this virtual function must be defined in that derived class. Okay, so I mean to say that this function, if registered IO object is defined here in object registry, so it here you can see that it is being derived in the object registry. So it is important that this function definition should be present in this class. So here you can see that this definition is given. Okay, so this pure virtual function definition you can find here, and the definition you can see here that it is been given here. Okay, so whenever the abstract class is being used, the definition of the pure virtual function should be written in the derived class. That is the concept of the abstract class. So you can see here that this is the concept of the abstract class, and it is being derived in the object registry, and finally the time has been derived from the object registry. Okay, now this is the structure of the complete object registry. So you can see that the object registry is being derived from the registered IO object and the hash table, and here you can find the pointer of the registered IO object. Okay, so I already explained you that this hash table, so means object registry is a registered IO object, as well as it is also derived from a hash table of a registered IOobject. Okay, so it will give a one table of the registered IOobject, and it will give a just a IOobject. Okay, so these two things has been derived in the object registry. Now this object registry is being derived in the time and polymesh and is the cloud. Okay, so cloud is something related to the parallel computing, but here two important things are the time and the polymesh. Now let me explain you in more detail. So what is happening here? Okay, so first thing that is important, that whenever you declare a object of a time, it is going to be registered in the object registry. Okay, so this is the first thing. Whenever you declare any object of the time, that is going to be registered in the object registry. Also, when you declare a mesh like polymesh, that is also going to be registered in the object registry. Okay, so I think let's go to the terminal. Then this concept will be more clear when we do some codings related to the object registry. So now in this understanding the registry, I have given three things, three test cases of the hash table. So you can understand the how hash table works. I'm not going to give much time here, but let me just use this code that I have modified some things here. So you can see here that I have created one hash table. So here you can find the keywords, and for that keyword there is a one value is given here. So this is the concept of the hash table, and you can just read the table, and then I am erasing the one keyword from the table. So you can see here that there are the one keyword that is the double AW. So I am deleting this value here, and then after erasing that I am printing that value. Okay, and here you can also use the find the method of that hash table, and there is a one method that is a TOC. So TOC is used to print the content of the table. Okay, so this method is going to print the content of the table here. Okay, further you can print the size of the table here. Okay, and if you want to change the value of a given keyword, you can use the method of that set, that is going to change the value, whatever the value you have write earlier, that value is going to change here. Further, you can also do the addition or subtraction to a given keyword. So this is going to call the value of the AW, and it is going to modify the value based on this calculation. So there are different things has been written here. You can just use that code and try to print this code on the screen, and then so I have compiled the code, and you can see here that different method is printing the different things. So let me just open it with the given solver. So you can see here that it is first printing the table before erasing anything. So this is the first table. Now this is the table. There are only 9 contents because we are deleting this double AW. Again we are printing the TOC, that is going to give them only the content of the table, I mean the keywords of the table. So you can see here that this TOC is printing here the content here only, and it is the sorted method. So it is going to sort the table based on the keywords you have provided. Okay, now it is printing the size here, what is the size of the table. Okay, so there are different things you can just correlate what is written in the coding and what is the printing on the screen. That is the simple things. You, I suggest you to go all these 3 folders given with this understanding registry. I will attach this folder into the GitHub. You can just find there. But now here let's understand the object registry concept. So let me go back and let me create one app. Okay. Now I'm going to do modification in this object registry. Let me just delete it. Okay. So this set root case is required because we are going to use create the mesh object also, and this is creating the time object. So as long as you created the object of time class, that is going to automatically register into the object registry. Okay, because we are using the method of the IO object, that IO object is going to create the class of the object of the time. And now let me just copy the meshing object from the understanding the meshing class. So if you have done this tutorial, these things you should find here. Okay, so I'm just copying. So it is going to create a mesh. Okay, that is kind of a big mesh, and it is going to use the method the IO object. Okay, so it is IO object we are using, and here you can see here that the region name we are providing a default region name. Okay, so the region name will be default, and now we are going to print some of the method of the IO object. Now to use this solver, I am going to use the case of the pits really. So let's create some variable also. So here the first variable I am creating, that is the pressure field, and you can see here that this is the IO object, and this is the mesh object that is going to create this dictionary. Okay, so this is the concept of the IO dictionary. Okay, now this IO dictionary is a constructor. So here we are creating a constructor of the p field. Okay, using the IO object and the mesh object. Okay, so two argument we are giving to create this dictionary. Now let me also create one variable, that is the u kind. Okay, and this is going to be vector field. There it will be u. So see what we are doing. We first created a time, and that is the top class object registry, and that time object, this time object is going to register this mesh object. Then this mesh has the every register of the p field or u field. Okay, and it makes sense because p field and u field are a kind of a list, and if you do not register this list into the mesh registry, it will not make any sense. Okay, so because this is the value scalar field, it is going to be registered for the mesh object only. Okay, so what will be just so first there will be time registry. Okay, now after the time registry there will be mesh registry, and then after mesh registry everything whatever field will create like p field or u field, it is going to structured like this in the object registry. So for example, I can print the names that is being registered in the time. Okay, so I'm going to print the whatever the registry that is being used in the this time registry, that I'm going to print here. Okay, also I'm going to print the different registry that is the registered in the mesh also. Okay, so there are one method that is the names that is going to print the values. Also you can use the p. Okay, sorry, you can use the database command, that is the db, that is going to list all the database that is present in the runtime object registry. Okay, so those two method I'm using here just to print the names and the data method. There are other things also, like there is a concept of the lookup. Okay, so lookup object is there. So what is this concept? If I see the source code of the object history, you can see that there are different methods is given. Like this name methods we are using to print the list of the objects we are which are being registered in the given object registry. Now there is a lookup class method and is a lookup object method. So this lookup object is very important. So let me copy some of the method from here. Now this is the second method that is I am going to use. So if there is a different object registry of a given class, like if you are different uh, class are there related to the only the value is color field, then this method you can use. And this is these two methods we are using for just for example. There are other methods like renaming you can use, and also you can check in or check out the registered objects. So there are different methods. Just you can look on this source code here. I'm going to here I'm going to look up for a given class. Okay. So for example, I'm going to create a volume scalar field from my side, and I'm going to name it as a pold, and I'm going to use this method. So first I have to call the registry, that is the mesh object registry I'm going to use. And from the mesh object registry, I am going to look up for a object. So that is why I'm going to call this lookup object method. And here I have to give this class type name. So here I'm going to specify the volume scalar field, and here I have to give a word. Okay, so for example, I'm going to look up for the p field. Okay, so what is going to do? It is going to find this volume scalar field p, and it is going to look up in the object registry, and then after finding it, it is going to store into the this pu field, and I'm print it on a screen just to show you. Okay, now similarly, I can print this the method, that is a second method. So to check that whether some field is present or not, that method is going to print using this method. Okay, so just for example, I'm showing that how can use this method. So I'm going to call this object registry, that is the mesh. Then I'm going to call this function object method, and again I'm going to specify the similar way that we have to give the template name. And this time let me just check this for the vector field. Okay, and here I'm going to u. Okay, so I think everything is right till now. So let me clean this. Let me again compile this. So it is compiled correctly. Now to use this application, we need a one test case. So maybe I can copy one tutorial from the incompressible simple form, and that is the fits daily case we can copy here. Okay, so you can see that there is a one fit daily test case, and first we need to create a mesh. Okay, now if I compile this object registry, you can see here that different things is being shown by this object registry. Okay, so let me just open it here, right, the left. So you can see here that first it is creating the time. So this create time dot h is creating the time. Then it is creating the mesh, but it is not printing anything on screen because we are not printing anything. Then it is going to read the velocity pressure field. Then it is going to read the velocity field, and we are printing the different objects from a given registry. So you can see here that the runtime object registry dot name is printing the whatever the fields are being registered in the time registry. Okay, so you can see that there is only one mesh. You can observe that is the region 0. Okay, so that is a by default region 0. So here you can see that we have just given that v dot default region. Okay, so this is the giving this name, that is the region 0. Now here we are printing the whatever the different registry in the mesh. So these are the different object registry present in the meshing registry. Okay. Now this database only shows the top level database. Okay, so you can see here that this region 01 and region 01, it is presented by using this method the db class. So it is db method just print the top level database. That now if we are here go this, we are using the mesh lookup object to find this p from the mesh object history, and when we are using this p bold. Okay, and here we are printing this p bold only, and you can see here that everything whatever the conditions you are given this p field in the 0 folder, this has been copied into the this p bold variable. Now since we were not creating this volume scalar field p bold using this IO object concept, that is why you can see here that it is not being registered in the IO mesh object registry. So you can see here that this p old is not registered here. Okay, now you can see here that this found method is presenting that whether this u vector field is present with this registry or not, and you can see that it is printing one. It means that object registry is present here. Okay, so that is something related to the concept of the single region. So when the meshing is only one, this concept is being presented here, but sometimes it happens that you have to work with the multiple meshes. So for example, if I give you example of the CST multi-region, there you work with the multiple meshes here. So for example, one mesh is related to the fluid, another mesh is related to the solid. So in such cases, what happens that you find only one time registry, and the other meshes, multiple meshes are registered with this time, and then for different mesh registry there will be different field variables. Okay, so what I mean, let me explain using an example. So let me go back. So again let me go back. So I am going to copy this object registry as a multi object registry folder. Okay, now we are going to do modification here only. Let me copy this name. Here I am going to just copy this name here, and in file folder I have to do some modification. Okay, now let's do modification this time. Here also, as I told you that the time registry will be only one, because I did not find a single case in OpenFOAM where you need to work for the multiple time zone. Okay, so in every case whatever you find solvers in OpenFOAM, there is only one create time class you can find, but meshes can be multiple. So therefore I can create one mesh, that is the mesh 01, and here maybe I can give this name as a fluid. So we are going to create one mesh related to fluid and another mesh that is related to the solid. We can give any name. Okay, so here I am going to name it as a solid, and here I am going to give it as a 02. Okay, now I am going to create a field for the solid and the fluid separately. Okay, so I'm going to create the pressure field, and now this should be new pointer you can use for creating a volume scalar field of p kind of for different meshes. So for example, this is the mesh 01, this is the mesh 01, and this is related to fluid. Similarly, I can create for the solid. Okay, solid here, and here also I can name it as a mesh 02. So this pressure field first I created using the mesh 01, and this I am creating using the mesh02. So because we are working with the multiple meshes, okay, one mesh is related to the solid field and one mesh is related to the fluid field. Okay, so now I will also edit here. So this is the velocity field for the solid fluid. And here again I am going to use this new method, and here this should be mesh01, this should be mesh01. Similarly, again I am going to create for the solid, and here again I am going to use the new. Now this time I am going to also give a one dictionary of the transport properties, and that is for only the mesh01 object registry. Okay, so I am going to just give a dictionary that is kind of dictionary for a mesh01. So this, since we are creating again using the IOobject concept, so this will going to registered into the registry object registry of the OpenFOAM. Okay, so what is happening here? So here first it is creating the time class. Okay, so this, as long as you created the time object, this is going to register in the object registry of the OpenFOAM. But for now, this object registry is registering two kind of mesh, that is the mesh1 and mesh02. Okay, so two kind of mesh regions are being registered in object registry, and from there, whatever the fields or IO dictionary you are going to create in object registry, that is going to be registered either for the mesh01. So first mesh01 will register the whatever the variables you are creating, you, and also we are creating the transport properties. Okay, okay, other things are that is the data related to meshing will be present, so like points, fields, all the data are related to the this mesh01 will be present. Okay, now the similar data will be present for the mesh02 because we are creating the multiple meshes for a given test case. Okay, so here the different data will be also present for the mesh02. Okay, but since this transport property dictionary we are creating only for the mesh01, so this will be not present here. Okay, so this is the working directory of this is the how this object registry registering the different fields in a multi-region solvers. Okay, now I can run this solver. Okay, somewhere some mistake is there. Okay, sorry. So since we have not created the mesh object, now we have created the either the mesh01 or mesh02, so that is why you have to specify here the mesh01, and here maybe we can specify the mesh02. So I think it should work now. Now there is a one test case that is a pits daily, and if we are going to run the pits daily test case, okay, it is going to show me error. Okay, because it is going to ask for the multiple meshes. Okay, so it is saying that this point is not present in the fluid polymesh. Okay, so in this pits daily case, there should be two folder, that is the fluid, and another should be that is the solid, and these two things should have this polymesh. Okay, so this fluid should have the polymesh and this solid should also have the polymesh. Now we are also registering this transport properties in the fluid, so it is going to look up for this transport properties in the fluid case. So we are not giving this transport properties for the solid, so it is not going to ask for the solid case. Okay, now again this p field and u field is going to be needed for the different meshes. Okay, so this p and u should be present in the both cases, both meshes. Now this, when you go to the system folder, there should be also two meshes should be required. Sorry, this would be flute. I think we have given the wrong names here. This F and S are the capitals. So now you can understand that while in every cases in OpenFOAM, there is only one control tick. Okay, because whatever the solvers you use in OpenFOAM, that always ask for the one time object. Okay, so only one time object is being registered in the object registry. That is why only one control you will find in the any test case of the OpenFOAM. But these things, FB scheme and FB solution are something that is related to the meshes. That is why it is going to be registered for the different mesh regions. Okay, so I am going to do this modification because there yes should be capital and here F should be capital. Two meshes, one is for solid and one is for fluid, and then from those mesh registry we are giving the boundary conditions, and here also we are giving the FB scheme and FB solution for the fluid and solid. This control dict is always one in every test cases of the OpenFOAM, so that is not our headache. Now let me first open this with the solver. So you can see that it is starting by creating the time, and then we are creating the pressure field and for solid and fluid, then velocity field for solid and fluid. So you can see that this P we have created for solid and fluid, U we have created for the solid and fluid. Now this transport properties we are only registering for the fluid field, and then we are printing the different names. So you can see that when we are calling the names for the runtime object registry, it is giving me two meshes. One is mesh related to the solid, one is the mesh related to the fluid. Okay. Earlier in the PITS daily case, there was only one region 01 mesh, and that is the default name we have given in that case. Okay. Now we can see that we are printing the values for the mesh 01. So here you can see that different values you can find here. Okay. That is the PU, and here let me not print the database, let me print the names for the mesh 02 also. Okay. So now you can see here that in the case of the mesh 01, in the case of mesh 01, there are 14 object registry, whereas in the case of the mesh 02, there is only 13 object are registered. Okay. So here this transport properties is only going to register for the mesh 01 because we are only calling for the mesh 01. Here we cannot find the object transport properties. Now you can observe that this, since we are not declaring this mu field using the IOobject concept, so you cannot find that mu field is being registered here. Okay, mu scalar quantity, that is the dimension scalar, is not being registered here because why it is happening, because we are calling this mu variable using the transport properties IO dictionary. Okay, so this transport properties is registered in this object registry of the mesh, but this mu is not registered. So when you want to use this variable mu, you can use the registered dictionary, that is the transport properties, and from those dictionary you can call this mu field. Okay, so this is the how this different variables is being registered in the object registry of the OpenFOAM. Now when you go to the this lookup, so you can see that this is the looking for the p field from the mesh 01 and it is copying the value, and here we have printed that the same things, and here we are finding out that whether this u field is present in this mesh 02 object registry or not. So you can see that it is printing 1, that means the yes, it is the present. What is the use of this object registry concept? So if you go to the foam src folder, Okay, and if you find out this command, that is the lookup object. So if you find out that there you can see that this lookup object is vastly used in src folder of the OpenFOAM. So you can see that they are looking for some variables from the this mesh registry. Okay, here you can see that they are looking for the different kind of variables from the registry of the meshes present in OpenFOAM. So that is why it is important. So when the object registry are registered in the some central registry, then from there you can just look up for those variables or those fields, and you can do the modification based on your requirement. Okay, so you can also see that this lookup object dot ref, that is one method from that object registry that is also being used. So that is why this object registry concept is important, and that is why I wanted to explain this before we go to the uh, modification to the boundary condition or creating some new boundary condition. These things are needed to know you at this level, and I think this concept is clear to you how this object registry works in OpenFOAM and how it can be useful for you. And if this level is understood by you, then we can do some solver modification in the coming tutorials. So next few tutorials I'm going to do I'm going to create some solvers and create some you can say create some boundary condition, and then after that I will go for the code stream. Okay, so please watch this video, and please subscribe my YouTube channel, and please share this video to more peoples, and I hope this video is helpful for you. So thank you for watching this video. Thanks to all of you for watching this.